So, hi everyone. Continuing in our lecture series for hierarchical cluster analysis, and this particular data set, we were able to come up with the output interpretations for all of these. So, proximity matrix, agglomeration schedule, cluster membership, all these were done. And today in this particular lecture, I'm going to explain particularly about the dendogram. Okay, so taking you where I left the last class. So in the last class, we were able to come up with this where I determined that, okay, so 4 cluster solution is our first best because this is where the percentage change in agglomeration coefficient was the highest. And then it was the second best solution to have a 3 cluster solution if at all the sample representativeness was not met in 4 cluster solution. But then we checked for sample representativeness and we said that, in the 4 cluster solution, it's just the second cluster which has 9 members in it. And this does not meet the criteria of minimum 10% of your sample being represented in each cluster. So in our sample being 100, so 10% of 100 is a 10. So that means in cluster 2, where you have 9 cases, it's falling short by 1 more case to complete or fulfill the sample representativeness criteria. So in such cases, I think you can be, you may be guided by your, underlying theory. So if you actually on the, outset of your project, onset of the project itself, you thought that you were to come up with a 4 cluster solution. So be it, it doesn't really harm. So let's say I am indeed going to take up a 4 cluster solution, and keeping this 4 cluster solution thing in mind, and also that keeping this table in mind, I'm now going to explain you what a dendogram is. So that's how your dendogram looks like. Firstly, this is your dendogram. And as you can see that because you have 100 cases, this dendogram is this massive. Now just imagine if these cases were way more than 100, this dendogram would have been way bigger and occupied a large amount of your output sheet. And this is the reason why hierarchical cluster analysis gets a little messier and less informative when you have a larger data set. So to interpret it in simple fashion, you can also export your dendogram in a PDF. So you go here, and then through this. So if you just go there and perform the right click, you will be able to see export, and then here select PDF. Okay, and then just select. So I just want to know. Okay, so that's a PDF, and then wherever you want to save, you can do it, and then click OK. So you will get a PDF format. I have already taken it out. So that's my PDF version of dendogram, which is however broken, but still it's a little comfortable to interpret. Now you must be wondering, every time do we have to go through this process? You are lucky if you have a higher version of SPSS. Unfortunately, I do not possess that right now. So I could not get dendogram with such beauty as you do get in higher versions of SPSS. So I do have the output saved from my earlier higher version of SPSS. So that's how you will also be able to obtain a dendogram if you have a higher version of SPSS. That's way more beautiful. It's in the form of an image, and its interpretation is also easier. So now let me talk about the interpretations finally. Dendogram is like a tree-like structure. Okay, so as you can see, this is a simpler format of dendogram which I have made over here. So here on this axis you have all the cases, and however on this axis you have the distance between the cases. Okay, so as you can see, this dendogram is made by some vertical lines and some horizontal lines. So our focus is also on understanding what these lines mean. So vertical lines represent the grouping of clusters or the stages of agglomeration schedule. You see this? So this number of clusters column is also your stages column, right? So this stages column is nothing but all the vertical lines on the agglomeration schedule. Okay? So you can also interpret it in this fashion. because this used to be your last stage, that is stage 99 in our case, and this used to represent a one cluster solution. That means जो last vertical line है आपका यहाँ पे, this last vertical line from left to right you have to look at it. Okay, so the last vertical line represents the last stage in agglomeration schedule and also a one cluster solution. तो इसका मतलब क्या है, all the cases have gotten combined in this one big cluster. ठीक है, so that you understood that vertical lines represent the grouping of clusters or stages of agglomeration schedule. Now talk about the horizontal lines. These indicate all the cases that are a part of one particular cluster. As you can see, ये horizontal line, this is an horizontal line. So this means that all these cases are a part of one cluster. A splitting of horizontal line into two indicates fusion of two clusters. Okay, so let's see that. So let's say this is a horizontal line, okay, and this further got split into two horizontal lines, this one and this one. So that meant that there is indeed a fusion of this 1 and 2. Okay, you get it? So if you have a splitting of one horizontal line into two horizontal lines, that means it is a fusion of two clusters. Okay. Now, longer the horizontal line stretches, the larger the distance it has traveled. You see, this is distance. Okay, this is the distance coefficient. Jiske basis where you have your agglomeration schedule, this is that distance coefficient. So if longer the horizontal line, that means the larger the distance is being captured. That means the likelihood of two very dissimilar clusters or two very dissimilar cases being combined increases. Okay, so for example, you see the longest horizontal line here is this one. Okay, and that means here at this point of time you have indeed combined very dissimilar cases. Okay, so that has actually resulted in a one cluster solution also here, and we all know that in a one cluster solution, as we are progressively moving, so here in the agglomeration schedule, so in a one cluster solution, that is towards the end here at stage 99, we are progressively moving along this column, which is the agglomeration coefficient. So this is your agglomeration coefficient. This is highly increasing, right? So this is increasing because this distance is increasing, right? So towards the last stages, we see that we are combining more and more dissimilar cases together. Why ho raha hai yahan pe? The similar thing is happening. This horizontal line is very long, and that actually indicates the last stage also, that is making of one big cluster. So you see that more and more dissimilar cases would have combined in this particular stage and in this cluster. Okay, so now you understood that vertical lines means grouping of clusters or stages of agglomeration schedule. Horizontal lines indicate all those cases which are a part of one cluster. Okay, it's like all the area between two horizontal lines is indicative of all the cases in that particular cluster. Okay, now what is the rule? So the rule is eliminate vertical lines, that is number of stages as obtained from the stopping rule in the agglomeration schedule. Then check your optimal number of cluster solution by looking at what all clusters are left via the virtue of horizontal lines. I just taught you that vertical lines represent the stages of agglomeration schedule. So in your agglomeration schedule, this last stage means a one cluster solution, as we have done over here. The last stage means a one cluster solution. The stage before it means a two cluster solution. Then stage here means a three cluster solution. And since we all are looking for a four cluster solution, that means these three should be eliminated. Okay, so these three stages or three types of cluster solutions are the ones represented in the form of vertical lines. Okay, so I repeat, so these vertical lines are representative of these cases. So you have to move from here to this point by eliminating the the clusters or the stages. So starting from here, if you were to eliminate the last three cluster solutions, as you saw here, so I want to eliminate all these three. Okay, so these three, so that I'll be left with the fourth one. So I have to eliminate the 3 vertical lines. Okay, so I eliminate this first vertical line. See what happens. So I'll tell you. So you get rid of this vertical line. Okay, and uske baad just look at the immediately closer vertical line. This is this one. This is higher at point, so this is relatively higher in point to this one. So once you have eliminated these two, I have to also eliminate the third vertical line. That means मुझे ये भी eliminate करना है. Now you look at the number of clusters left via the virtue of horizontal lines. मतलब दो horizontal lines के बीच जितने भी cases हैं आपके, those are representative of all the cases. Those are a part of one cluster. So now you are left with this, 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 and this. You see that? So by eliminating the 3 vertical lines, जो कि हमें stopping rule से मिला था. So I got from my stopping rule that get rid of last 3 vertical lines. I eliminated those 3 vertical lines and I'm left with the 4 cluster solution. Okay. Now if this is clear, I'll explain this through actual dendogram obtained now. So this is your dendogram which you have obtained from your model. So since you have to get rid of the vertical lines, so I've eliminated this first vertical line here. Then immediately closer देखो कौन सा line आ रहा है vertical में, this one. So this second vertical line eliminated. Now this third vertical line eliminated. Now remember, I've eliminated this one, and this one. Now imagine that these are out of your diagram such that this vertical line does not exist, this does not exist, and this does not exist. Now look at the horizontal lines combining cases. So see, this horizontal line and this horizontal line combines your one cluster. Now come over here. This horizontal line and this horizontal line combines your second cluster. And then this horizontal line, then this horizontal line. Okay, यहाँ पे देखो अब यहाँ पे आ रही है horizontal line. So these two horizontal lines are combining your another third cluster. So that's your cluster 1, cluster 2, cluster 3. Now come over here. These two horizontal lines, so this one and this one, is combining all these cases to become the 4th cluster. Okay, so that's how you have obtained your 4 cluster solution. I'll repeat. So I were to get rid of 3 vertical lines because those are the last 3 cases or stages in agglomeration schedule. So that is this stage, and this stage. Once you get rid of these, just look at the number of clusters left. So this is your 1 cluster, as you can see through this horizontal line and this horizontal line. And then this is your 2nd cluster. You come over here, this is your 3rd cluster, okay, by the virtue of these 2 horizontal lines. And then by the virtue of this and this horizontal line, you have your last and the biggest cluster, that is the 4th cluster. Okay, so that's how you can interpret agglomeration schedule, which is nothing but a tree-like structure. So we have indeed proven that in hierarchical cluster analysis, you proceed from n is to 1. So initially, you see on this axis, all these small boxes are indicative that each person has started as a cluster. Then they got combined, and at the end, we were left with this longest vertical line, indicating that one big cluster solution remains. Okay, so that's how you have to go about the interpretation of dendogram. Thank you for watching the video.